Hello everyone. Today we are going to discuss the lecture number 8 of induction machine. In this lecture we will discuss induction generator. Till now we have covered the induction motor topics, torque slip characteristics, speed control, starting methods. In this lecture we will discuss how induction generator works. Induction generator is nothing but induction motor. When induction motor is running as uh, above the synchronous speed, it start behaves like induction generator. The only condition is that the rotor speed should be greater than synchronous speed. When the speed of the rotor is greater than synchronous speed, then it will deliver power to the system. An induction generator receives its excitation or magnetization current from the system to which it is connected. So, for the it is one of the necessary condition that its excitation current is supplied by the system to which it is connected. Therefore, it put one restriction on the machine that it will not be able to work under isolation system. It is not successful for isolated system. It consumes reactive power rather than supplying the reactive power. It only supplies the real power only, that is kilowatt. So this is one of the restriction of induction generator, that it only supplies real power to the system and it consumes the reactive power from the system, and the reactive power supplied to the induction generator plus other loads is taken care by the synchronous generator or static capacitor connected to the system. So I will tell you that when induction generator is rotor is running above synchronous speed, then slip automatically, you know that slip is nothing but slip is uh, ns minus n upon ns. So if nr is greater than ns, this means that slip becomes negative. Slips becomes negative or less than 0. So this is the condition for induction generator, that the induction generator slip is negative, and the torque, current and efficiency and power factor will not differ greatly from that when it is operating at motor. The torque slip characteristic is same as it is for the induction motor. The only difference is that it gets reversed in the shape. So torque is generated negative side, and rest all the curve is same as it is in the case of induction motor. So now let us consider how it works. For example, consider a 3600 rpm squirrel cage induction motor which delivers full load output at 3550 rpm. So it is working as motor. It delivers full load at rated rpm less than 50 rpm. But when it is running as generator, then this 50 rpm is added to the synchronous speed, and it is running as 3650 rpm, that is above the synchronous speed. And uh, if the motor is running at half load at 35770 rpm, means 30 rpm difference is there from the rated speed, then if we want it to run as generator, then as for output as a generator, the machine should run as 3630 rpm. So we can conclude that only the same difference is added to the rated speed if we want it to be run as the generator. Now let us discuss some advantages of the induction generator. It is less expensive, more readily available than synchronous generator, does not require DC field excitation voltage as we get it from power supply to which it is connected. It automatically synchronizes with the power system, so its control is simple and less expensive. Now the disadvantages of induction generator is it is not suitable for isolation operation, because I discussed that excitation requirement is met only by the power system to which it is connected. Therefore, isolated operation is not possible. It consumes rather than supplying the kVAR. So it is not useful where kVAR requirement is there. So it will somehow unable to meet the requirement of kVAR. It cannot contribute to the maintenance of system voltage levels. Its efficiency is also low. So these are all advantage and disadvantage of induction generator. Now, as energy cost is high, energy recovery becomes an important part of the economics. Therefore, the induction generator is ideal for such applications because it requires very little way of control system or maintenance. Because of their simplicity and small size per kilowatt output power, induction generators are very strongly favored for small windmills. So one of the application of induction generator is used in windmills, and commercially it is designed to operate in parallel with large power systems supplying a fraction of customers' total power needs. In such operation, the power system can rely only on for voltage and frequency control. Static capacitors can be used for the power factor correction because kVAR requirement is not met with the help of induction generator. So we need some external help for in the form of static capacitors to meet the kVAR requirement. So this is all about the induction generator. So we will discuss next topic in the next lecture. Till then, goodbye. Thank you.